The ocean pulls back first. That's your only warning. If you ever stand on a beach in Oregon or Washington and watch the water retreat further than you've ever seen, exposing rocks, stranded fish, and sand that's usually 40 feet underwater, you have maybe 15 minutes, maybe less. You run uphill immediately. Don't grab your phone. Don't try to film it. What pulled that water out is about to send it right back as a massive wall. Scientists call it a mega-tsunami, and the fault line that generates it off the west coast isn't some theoretical scenario. It's real, it's overdue, and it sits 70 miles offshore, buried under cold gray water, quiet for over 300 years. The Cascadia Subduction Zone runs 600 miles from Northern California all the way past Vancouver Island. It's two giant tectonic plates locked together, one grinding beneath the other, storing pressure like a bent steel beam right before it snaps. Every geologist studying it agrees it's a matter of when, not if. When it lets go, the shaking could last 6 minutes. And then the sea comes for the coast. This isn't like the earthquakes people picture in California. The San Andreas slides sideways. It rattles cities. But Cascadia is a megathrust fault, meaning it lifts the entire seafloor upward in an instant. That vertical movement displaces a staggering amount of water, and physics does the rest. Waves travel at the speed of a jetliner in open water, then pile up as they hit the shallow coast, stacking into surges 30, 50, or even 100 feet high. We know this happened because the coast left behind physical proof. Ghost forests along the Oregon coast, dead cedar trees with roots drowned in salt when the ground dropped and the sea rushed in. Layers of ocean sand buried in coastal marshes, covered by centuries of mud. And then there's the record across the Pacific in Japanese temple archives. Scribes recorded an orphan tsunami on the night of January 26, 1700, with no local earthquake to explain it. Scientists later matched the timing. The parent quake hit Cascadia at roughly a magnitude 9.0, sending waves all the way across the Pacific. That was 1700. The average gap between these events is roughly 240 years, though they can happen 200 years apart or 800 years apart. Look at the math. We're living right inside that window. So the question isn't whether the wave is coming. The real question is, when it hits, which cities take the brunt of it first? Which places have the least warning, the lowest ground, and the most people packed into the path? I looked through the inundation models, evacuation studies, and population maps. 7 cities kept coming up, and the order they'd take the hit isn't what you'd expect. Let's start where the wave hits soonest and hardest. Seaside, Oregon. It has about 7,000 permanent residents. But summer tourists push that number way higher. Emergency planners lose sleep over this town more than almost anywhere else on the coast. Geography completely betrayed it. Seaside sits on a flat spit of land surrounded by the Nicanicum River and the ocean, with basically no high ground in town. Modeling shows water rushing across the entire built-up area. On top of that, thousands of people need to cross bridges to reach safety, bridges that a magnitude 9 quake shaking for 5 straight minutes will likely drop right into the river. Think about that timeline. The shaking stops. People are dazed, injured, standing in rubble. They have maybe 20 minutes before the first wave arrives, and their escape routes are destroyed. Seaside built a new school on higher ground specifically because the old one sat right in the inundation zone, which will save hundreds of kids. But on a packed August afternoon, the evacuation math is brutal. Now move south and slightly inland to a city most people would never expect to see on a tsunami list. Portland, Oregon. Portland is 70 miles up the Columbia and Willamette rivers, which seems safe, but that's the trap. Portland won't get hit by a 50-foot ocean wave. Instead, Portland gets hit by the earthquake itself, which is a massive problem for a metro area of 2 million people. The city sits on soft river sediment that amplifies shaking and triggers liquefaction, turning solid ground into liquid mud. The fuel storage terminals along the Willamette, the harbor, and older brick buildings downtown are extremely vulnerable. There's a strip called the Critical Energy Infrastructure Hub, where most of Oregon's liquid fuel sits in tanks built directly on liquefiable soil. If those tanks rupture, the fuel spills into the river, wiping out the state's gasoline and jet fuel supply right when rescue teams need it most. Portland gets cut off, with broken bridges and damaged airport runways. It gets crippled by broken infrastructure rather than seawater. Back on the coast in Washington, there's another location anyone who's driven Highway 101 should know about. Ocean Shores, Washington. This resort town sits on a flat, sandy peninsula sticking out into the Pacific. On weekends, it fills up with visitors from Seattle and Tacoma coming for the beach. Almost none of them realize the ground beneath them is barely above sea level, with no natural high ground for miles. Washington recognized this risk and built a vertical evacuation structure in nearby Westport, a reinforced concrete tower and berm designed so people can climb above the wave when they can't run horizontally. It's a clear admission of reality. In some places, you can't outrun the water, so your only option is to go up. Ocean Shores remains completely exposed, relying on a single access road that will likely fail during the quake. People usually picture a tsunami as one massive cinematic wave. That's not how it plays out. A Cascadia Tsunami comes as a series of surges spread over several hours. Often the second or third wave is the one that catches people, because survivors go back down to check on their homes or search for family. We saw this during the 2011 Tohoku disaster in Japan. That magnitude 9 megathrust quake killed nearly 20,000 people in a country with seawalls, regular drills, and advanced warning systems. Japan in 2011 shows what happens to a highly prepared country. Now imagine that same event hitting a coastline where most people have never run an evacuation drill and half the crowd on the beach is on vacation. That brings us to the fourth city, Crescent City, California. This town has a heavy history with tsunamis. In 1964, the magnitude 9 Second Alaska earthquake sent waves straight down the coast that funneled into Crescent City's harbor, killing 11 people over 1,000 miles from the epicenter. The shape of the seafloor and harbor acts like a lens, focusing incoming wave energy directly into the town. It's officially the most tsunami-prone city on the West Coast, hit over 30 times by measurable waves since records began. Cascadia's southern end sits right offshore from Crescent City. A local rupture wouldn't give people hours of lead time like the Alaska quake did. Waves would arrive in minutes. A harbor that amplifies distant waves will do the exact same thing to a local wave, making this a worst-case scenario for a town that has already spent decades rebuilding from past hits. Further north sits another vulnerable spot where timing is everything. Astoria, Oregon, located right at the mouth of the Columbia River. Astoria is one of the oldest settlements west of the Rockies, with much of its historic downtown and waterfront built on low-filled dirt. When Cascadia ruptures, Astoria gets hit from two directions: heavy shaking that threatens the massive Astoria Megler Bridge, followed by a tsunami surging directly up the river channel. Nearby coastal towns have mapped out precise evacuation times, and the reality is tough to look at. Some neighborhoods sit so low that reaching safety within the time window is almost impossible for anyone with mobility issues, like the elderly or hospital patients. Evacuation maps usually base their estimates on healthy adults walking briskly, which doesn't match how real communities are built. Why hasn't this happened recently? Why do scientists call it overdue if the fault is quiet? Faults don't follow a calendar, they build up strain. Right now, the Juan de Fuca plate is sliding beneath the North American plate, dragging the coastline down and westward. GPS stations measure the land compressing and rising a few millimeters each year, storing energy like a compressed spring. When the lock breaks, all that energy releases at once. The coastline drops several feet in seconds, while the offshore seafloor jumps upward. Scientists also know the fault can break in sections. Sometimes all 600 miles snap at once in a magnitude 9 event. Other times, only the southern section breaks. Because the southern segment near California and southern Oregon breaks more frequently, cities down there face these events on a tighter timeline than northern spots. City number 6 is the biggest one on the list. Seattle doesn't face the main ocean wave directly because Puget Sound sits protected behind the Olympic Peninsula. Instead, Seattle's threat comes from the Seattle Fault, which runs directly under the city and the sound. When that fault ruptures, which last happened around 900 AD, it generates a tsunami inside Puget Sound itself. Models show waves hitting the waterfront, Alki Beach, and Bainbridge Island in a matter of minutes. Even without an in-sound wave, the main Cascadia quake poses a massive hazard. Seattle has entire districts built on filled tidelands, including the industrial area, parts of Pioneer Square, and the Stadium District. That soil will liquefy under minutes of heavy shaking. Combine prolonged shaking, soil liquefaction, and a potential local wave, and a major population center faces immediate disruption. The seventh area is often overlooked. Vancouver and the British Columbia coast, particularly exposed towns like Tofino and Ucluelet on the west side of Vancouver Island. Tofino is a small, isolated surf town directly facing the Pacific. It relies on a single road for access. When a wave hits, people there face the exact same challenge as Seaside: flat terrain, limited high ground, and a single exit route that could be damaged by the quake. Greater Vancouver itself holds over 2.5 million people. While Vancouver Island blocks the direct ocean surge, the metro area will experience intense, long-duration shaking that threatens high rises and older infrastructure. So those are the seven: Seaside, Portland, Ocean Shores, Crescent City, Astoria, Seattle, and the British Columbia coast around Vancouver and its outer island towns. Each faces a different combination of hazards, but all sit right in the path of the same fault line. The science behind this is solid, and no geologist disputes that Cascadia will break again. The timing is the only unknown. It could be 100 years from now, or it could happen today. Japan lost thousands of people in 2011, but saved far more because of decades of preparation, seawalls, and mandatory drills. In Kamaishi, school children evacuated to high ground instantly because they had practiced the route until it became second nature. That's the approach the West Coast needs. If you're near the ocean and feel strong shaking for more than 20 seconds, treat that shaking as your immediate warning. You won't get a phone alert in time because the quake and the wave start at the same source. If the ocean pulls back unexpectedly, move inland and head uphill immediately. Don't go back down until authorities give a clear instruction that the danger has passed. The Cascadia Fault has stayed quiet since 1700, when its last major wave crossed the Pacific. Offshore, that spring continues to wind tighter every year. When it finally releases, the ocean will pull back first, giving anyone who knows what to look for a small window to reach high.